Know by definition that if you are looking for the definite integral, that's the integral from a to b of f of x dx, that will be equal to the limit as n goes to infinity of the sum as I goes from 1 to n of f of x sub I star times delta x. Okay? So the definite integral is by definition the limit of the Riemann sum. So what's happening in the integral? Well, this is the integral sign. It looks like an elongated S because it really is reminiscent that we are going to be taking the sum, just as the Riemann sum tells us. All right, there are things called bounds of integration. These happen here. These are the bounds of integration. These are always written in terms of the independent variable. Inside of here, f of x is called the integrand. And lastly, we have this dx, and dx indicates which the independent variable is. And it also tells us what we are integrating with respect to. So WRT is with respect to. So if there's a dx at the end of that definite integral, we are integrating with respect to x. Okay, so let's express a Riemann sum as a definite integral. So, for example, let's say we're looking at the Riemann sum as n goes to infinity of the sum as I goes from 1 to n of x sub I cubed plus x sub I times the sine of x sub I times delta x. We can also use stars here if you'd like. That would be fine. Okay. Just gets a little messy there with that cube. But anyway, let's see how this all plays out. So by definition, this will be the definite integral. Here's the sum. The sum turns into the integral sign. Oh, they have to tell us, we need a little bit more for this example. We want to write this as an integral over 0 to pi. Okay. Oops. Inclusive. So now this 0 to pi, these are our bounds of integration, so I write them here, 0 to pi. The function comes from here. Wherever you see the x sub I stars, you just replace it with x, so our function is x cubed plus x times the sine of x, and the delta x turns into dx. And that's it. That's how we've expressed the limit of the Riemann sum as the definite integral.